In this video, we're going to be working on an example, and this example is a little bit closer to what you might expect to see in your exam. And we're working on a problem that has to do with the intersection between a circle and a line. So let's just jump straight into it, right? So we are given that a circle has the equation x squared plus y squared minus 6y is equal to -4. And a line has an equation 2y minus x is equal to k, where I should have written here that k is a constant. All right, where k is a constant, right? So the first question is find the radius and the center of the circle. So when it comes to radius and the center of the circle, usually we can read those straight off the equation of the circle, right? We need it to be in the form x minus x1 squared plus y minus y1 squared is equal to r squared, right? So we need it to be in this form. So if it's not given in this form, which, is the case in this example, we need to make sure that we can convert it from this form into this, and then we can read it straight off here, because the coordinates of the center would be, this would be the x coordinate of your center, this would be y coordinate of the center, and the r will be the radius of the circle. Right. So now how do we go from this to this? Essentially, we need to do this by completing the square. All right. So we need to complete the square. Completing the square. Okay. Right. So we're going to take our example. All right. We're going to say our equation rather. So we have x squared plus y squared minus 6y is equal to -4. Right. So the thing is, we looking at our equation, right? Usually when you have, let's say, for example, when you have x squared, when there is another term that has an x, that means x has been expanded, right? In this case, x is on its own over here. There's no other term that has an x, which means there's no expansion that's actually happened, right? So x doesn't actually need to be completed. I mean, we don't need to complete the square with x. However, with the y expressions, right? So contrary to x, we have a y squared, and then we have another term over here that has y. So in this case, we can compress these two using completing the square into this form, right? So we can ignore our x, right? But for the y, let's just take the y, we can say y squared minus 6y is the same as saying, right? So for completing the square, what we usually do is we say, we take the b value, which is the value that's attached to the y in this case, right? And we say, okay, b is -6. So we want to identify that so we can get the b over 2, right? So the b over 2 is the same as -6 over 2, that's -3. So what we're going to do is we're going to say, okay, to our expression, we're going to say y squared minus 6y, right? So this is the expression that we had before. We're going to add and subtract the square of this b over 2, right? So we need to add the square of -3, but we also need to subtract the exact same expression, the exact same term, right? So what that's going to do is these first three expressions over here would then compress into whatever's being squared over here, which is your y, whatever's being squared over here, which is the -3, and then squared. So all three of these terms have compressed into this, right? And then we still have this term that's left over there, which is negative. -3 squared is +9, so that's going to be -9. All right, so essentially that's how we complete the square. The reason why we don't need to do that for x is because there's no b term, right? So there's no other term that we need to compress together with. So we can now rewrite our expression into x squared plus, now instead of saying plus these two, now we can write it as plus y minus 3 squared minus 9. That's equal to -4, right? Cool. So remember this term here turned into this. So we just exchange those two in our equation. Right, so now we can move on, right? So now we have x squared plus y minus 3. I'm going to take the constant term, so that's going to be squared. I'm going to take the constant terms to the other side. So this becomes, when it crosses over, it becomes +9. So it becomes 9 minus 4. So now we have x squared plus y minus 3 squared is equal to 9 minus 4, which is positive 5. Okay, so now this is the expression as we wanted, right? So even though it doesn't necessarily exactly look like this, right? Because our x doesn't have a bracket. So we can actually just rewrite this as x squared is the same as saying x minus 0 squared. So that now it looks exactly like this expression over here. So I have x minus 0 squared, y minus 3 squared, that's equal to some constant value. Which means at this stage, now we can directly read them because this is your, whatever you're subtracting over there is your x1, whatever you're subtracting over there is your y1, and then whatever's being squared over here, whatever's on this side is basically r squared. That means the coordinates of the center, right? So the center is going to be x value of, this is minus 0, so it means it's 0. This is minus 3, which means you're subtracting a positive 3. And then over here, so your radius, your r squared, is actually equal to 5. All right, remember that value is r squared. To get the radius, you need to find the square root of whatever's happening on the other side, right? So your radius is going to be the square root of 5. Remember, this is usually positive or negative, but a radius can't be negative, so you're always going to take the positive value to get radius. So the radius in this case is root 5, or positive root 5. Okay, so that is your first, those are your first two, the answers for the first part of the question, which was just find the radius and the center of the circle. Okay, second question then says, find the values of s. This is not supposed to be s. This is supposed to be values of k, for which the circle and the line have two distinct points of intersection, right? So what we're going to do is we're going to rewrite this expression. I'm going to write them in this form, right? In fact, I'm going to write it as x squared. All right, so let's write this. You have x squared plus y minus 3 squared is equal to 5. And then the equation of the line was 2y minus x is equal to k. 2y minus x is equal to k. So this is a straight line, right? So it's just that we have moved around the x's and the y's and all of that stuff, but it does still follow the equation y is equal to mx plus c. Right, so that's a straight line. So we have a straight line and we have a circle. Okay, so the question says find the values of k, right? K is this expression, this constant value over here, for which the circle and the line have two distinct points of intersection. So at this point, maybe we can even, points of intersection, right? That's an important piece of information. And the fact that we have two of them, right? Let me just use a different mark over here. Two distinct, right? What does each of those two mean? Points of intersection, nope. Right, points of intersection tells us that we need to use simultaneous equations to solve, right? So that means you have to substitute one equation into another, right, to combine the two. And then the fact that you have two distinct equations, this is going to result in you getting a quadratic equation. So you're going to get a quadratic equation from this. And then that quadratic has a determinant, which we denote by using this symbol. If I tell you that it has two distinct points of intersection, the determinant of that quadratic is going to be greater than 0. All right, so those are the two pieces of information that we need to join together to try to solve this problem, right? So how can we then do this, right? So we're going to need to make one of these. You take this equation, make either x or y the subject of the formula, and then you can replace into that equation. The easiest one for us is going to be x because it's on its own. There's no division that's going to be necessary there. So what we're going to do is we're going to say, okay, 2y minus x is equal to k. I'm going to switch the x and the y. I mean the x and the k. So when the x goes to that side, it becomes positive x. When the k comes to that side, it becomes negative k. So our equation is going to become 2y, that didn't change. This is minus k because when the minus went to the other side, it was negative. That's equal to positive x. All right, so now we have an x expression. So that means now we can take that x expression, this expression over here, and now we can substitute it into that equation over there. Right there. So now for your circle, instead of having x squared plus this, the rest of it, now we can say this squared, because remember, this expression is replacing x. So instead of having x squared, now we have 2y minus k squared, because this is your new x, right? And then that's plus everything else. There's no other x, so we don't need to do any further substitutions, is equal to 5. Right, then we simplify the expression. So we've got two brackets, we can expand those brackets, right? So with expansion, again, you can always do FOIL on the side if that works for you. But I'm going to do a faster method of expanding, right? So which basically goes like this. 2y minus k squared is, so you take 2y, you square that expression. That's going to be 2 squared, which is 4, and then y squared, which is y squared. And then we're going to say 2y multiplied by negative k, which is negative 2y, negative 2ky. But then that's going to appear twice. So it means we need to multiply by 2. So that's going to be negative 4ky. And then you take this other term here, and that's negative k squared. So negative k times negative k, because you've got two negative, it becomes positive. That's k squared. Plus, do the exact same thing over here. Y squared is just y squared. Y times negative 3 is negative 3y. It appears twice, so you need to multiply by 2. It becomes negative 6y. Negative 3 squared is positive 9. And then I'm also, because we know that this is usually going to give you a quadratic, right? Especially once you do a lot of examples, you can see that, okay, I'm always going to get a quadratic in this case. And then when solving quadratics, we usually want to take everything to one side. So that's going to be, so we're going to take the 5 to that side. It becomes negative 5. So this is positive 9 minus 5. And that's equal to 0, because there's nothing else on that side that's left. Next thing we need to do is, because again, it's a quadratic, and we're solving a quadratic in terms of y. So which means we need to group the y squareds. So the reason why I want to emphasize the y is because there's also the k squareds, right? This equation is in terms of y. We're trying to solve for y. So remember, don't confuse the y squareds and the k squareds, right? So we need, in a quadratic, we have a squared term, but it's only the y squared term, not the k squared, right? So let's just make sure that we don't get confused by that, right? So first thing we need to do is we need to group our y squared terms, which is this one and this one, right? Those are y squared terms. So let's bring those two together. All right, so that's going to be 4y squared plus y squared. The next group that we want to group together is going to be the y's, right? That's going to be this y and then that y, right? Let's bring those together. That's going to be negative 4ky minus 6y. The next group that we want to bring together are the constants. Now the constants, even though there's k squared and all of that stuff, a constant in a y equation is a term that doesn't have a y, right? So in this case, that's going to be, which color would be used here? Let's just go blue. This doesn't have a y. This doesn't have a y, right? So we can actually just rewrite this as plus 9 minus 5. But let's not jump steps. Okay, so we're going to write this as plus k squared plus 9 minus 5. So let's then simplify our expression. 4y squared plus y squared is 5y squared minus, these two can just stay as, because these are not the same, right? This one has a k, this one doesn't have a k, so they're not, we can't really join them like that. And then plus k squared, positive 9 minus 5 is positive 4, is equal to 0. Now, I like to then rewrite them as this, right? I like to rewrite them as y squared with its coefficient, that's 5. And then the next one is going to be the y term. What's the coefficient? So essentially, we're taking these y's and we're going to factor out a y, right? So that we're left with negative 4k minus 6. So it can clearly tell us what the coefficient of y is. And then you have the constant, which is just a k squared plus 4. That's equal to 0, right? So this is the y expression, right? It has an a, b, and a c, a y squared term, a y, and a constant. So why is this important? Because now we have to go back to our determinant stuff. The fact that we have been told that we have two distinct points of intersection should tell us that the determinant of this equation, which is the same as saying the b squared minus 4ac, this expression should be greater than 0. All right. So what k values are going to make sure that this expression stays positive, right? So now we're going to take that expression, right? So let's just take this, maybe let's push this down a little bit more, because now we need to make sure that we've identified from this expression, we know that our A value, which is this one, is 5. Our B value is this expression, which is negative 4k minus 6. Then our C value is k squared plus 4, right? That means our determinant equation, right? So I know this is going to be positive, but let's just simplify our determinant, right? So our determinant is going to be b squared. Actually, maybe I'm just going to write it like this. Determinant is your b squared, which is this expression squared, minus 6. We're not equating it to 0 yet, or, saying it's greater than 0. All I just want is just get this expression and simplify it, and then we'll do the greater than 0 thing, right? So just to make that clear, so it's squared and then minus 4 multiplied by a, which is 5, multiplied by c, which is k squared plus 4, right? Cool. So then we're going to say, okay, so this squared, again, same method, negative 4k squared is positive 16, right? Because negative 4 squared is positive 16, and then k squared. And then we're going to say negative 4k multiplied by negative 6. That's a positive, right? But it's positive 24k. But remember, it appears twice, so it's going to become positive 48. Positive 48k. And then negative 6 squared is positive 36. And then this is minus. Okay, so I'm going to jump steps here, right? Just a little bit. Hopefully this is not too confusing, right? 4 times 5, these two are going to give us 20. That 20, or at least negative 20, because it's negative 4 times 5, that's negative 20. That's 20 is going to multiply by this part of the bracket and by that part of the bracket. So those are the two expressions we need. Okay, so negative 20 times k squared, that's going to give you negative 20k squared. Negative 20 multiplied by 4, that's going to give you negative 80. All right, then let's simplify the expression. The expression now is going to be 16, actually group your squareds again, right? So that's going to be, take your k squared and k squared. I know we had said k was a constant, but remember this expression is now in terms of k, because now we're focusing on the different k values that would give you certain determinants out, right? So now we're grouping our k squared expressions. So that's going to be 16 minus 20. That's going to be 4, or at least negative 4 k squared. The next group is going to be your k's. There's only one of those. So we can just rewrite that as is. That's positive 48k. And then lastly, we have constants. So 36 minus 80. 36 minus 80 gives you negative 44. And this is your determinant, right? So now we haven't really done anything in terms of, like, I know we identified it here that it's supposed to be positive, but up until this point, all we just wanted to do was to get an expression of our determinant, right? To say, okay, different. Now I need to emphasize this because at some point, this is where it kind of gets a little confusing, right? Because we're going to say different values of k will give you different values of determinant, right? So for instance, if I put a k is equal to 0, this becomes 0, this becomes 0, this becomes negative 4. So your determinant is going to become negative 44, right? If I put a different value of k out, I'm going to get a different determinant out. So essentially what we're saying is different k values will output different determinants out. For our specific problem in this question, we're saying, okay, our determinant, which is negative 4k squared plus 48k, minus 44, what are the different k values that will make sure that this is going to be positive? So that's what we need to get. However, the key to solving this problem comes from understanding that this is an expression. It's an expression with an input and an output, which means it's its own function, right? It's its own function. So we can actually plot this on a graph. So that's what we're going to do. So in order for us to just visualize what's going on, right, I have plotted our equation for our determinant. So essentially, it's the equation where we have, this is the determinant expression, and then this is the actual determinant. So we're saying that different values of k would output specific values of your determinant. For example, right, if I put the number 2, so treat the k in this case as your x-axis, as you would normally do your x-axis. If I put a value of 2, okay, this is a bit of a high example, but okay, let me just use that one. If I put a value of 6, I'm going to get a determinant of positive 100. If I put another value, I'm going to get a specific value of determinant out. However, if you focus on this specific point over there, the point where if my k is 1, my determinant is going to be 0, right? So this is the point that tells us that when it crosses over this line, you only have your determinant is 0, which means you have a tangent, right? And then when it goes to the positive, when it crosses over to give you, because remember, your determinant is your y. In this case, is the output. Your y is always just going to be your output. So if I put a specific value, so like, for example, if when I put 6 in, it gave me a positive value. So any number that was above 1, the graph came to the positive y direction, which is the cases where your determinant is positive. So this graph shows us the different values of k that give us different determinants in the output, but it doesn't really matter what the actual numbers are. Remember, your determinant, all we care about is when your determinant is 0, which is along this line, when your determinant is positive, which is above the x-axis, and when your determinant is negative, which is below the x-axis. So all of these different values of k would give you negative determinants. This specific one will just give you a determinant of 0, and then all of these values where the graph is above the x-axis would give you positive determinants, right? So essentially the question in this case is asking which are the values that would give you positive determinant. And just by looking at the graph, we're going to solve this just now, but by looking at the graph, when the graph goes from 1 to 2 to 3, all of these different x values are pointing to positive y values, or all of these different values of k are giving positive d values. So anywhere between this one, so the graph is going to be positive from 1 until 11. That's where the determinant is positive because it's in the positive y direction, as the positive determinant direction. Hopefully that makes sense. So coming back to our problem, right? So even though we're focusing on this expression, even though we're focusing on greater than 0, all this tells us is which are the cases where the graph is positive, right? And just to sketch this again, right? Because since this is a quadratic, if you say d is equal to something, this is a quadratic equation because it has a squared expression for k, and we know that your negative a. Your a is going to give you the shape of the graph, right? So I know that my graph is frowning. So maybe if I sketch it like this, right? So this is what the graph looks like. Maybe let's just change the color. So we know that the graph looks like this, right? And by the illustration that we've just talked about here, we said, okay, because this is the graph where you have the input is k and then your output is determinant. So we're saying that when the graph is in this area over here, your determinant is negative, which means you have no solutions. When your graph is on this line over here, it means your output is 0, right? Anywhere along this line over here, it means your determinant, your output is equal to 0, which means we're focusing on tangents. If your graph is above here, it means the different k values. For example, if you take this k value over here, you map it onto the graph, it will give you a positive determinant. So that means your determinant in this area is going to be positive, which means you have two distinct solutions. So we are just asking ourselves, okay, what are the values where the graph just goes above that x-axis? So in order for us to do that, we're just going to say, okay, right, I know the question is asking for greater than, but we are going to then ask the question, okay, what are these points where the graph crosses there and the graph crosses there? Because we know that in between those 2 points, that's where it goes above the x-axis. So we're going to solve for this for when it's equal to 0. So we're saying, okay, negative 4k squared plus 48k minus 44 is equal to 0. So we can now use the quadratic formula. For the quadratic formula, I'm just going to try to go through this very quickly. We need the a value, right? And the annoying thing about this problem is that you have a quadratic that then turns into another quadratic. And I know that is tricky, but hopefully with, these explanations make sense. And with practice, you get more comfortable with questions like this. Okay, so we're saying to solve for k, we're going to just use the quadratic formula. We say negative b, which is negative 48, plus minus the square root of b squared, which is 48 squared, minus 4 times a, which is negative 4, times c, which is negative 44, and then you divide by 2 multiplied by negative 4. So whether you throw that right into your calculator, or if you're like me and you need to punch it in, remember when you're punching it in, you need to solve for when this is positive and when that is negative to give you two separate answers. That's going to be 4. I'm just punching that into my calculator. That's 2 multiplied by negative 4. That gives you positive 1. So when it's positive, when that sign is positive, it gave me a k value that's equal to positive 1. If I go back to my same calculation in my calculator and I change that sign to negative, it gave me positive 11. So, right? So now the confusing thing is but why did we equate this to 0? Because we're saying that the determinant is equal to 0, and that's not the question, right? Why is it that we are not saying greater than 0? Because all we're saying is okay, we just want to know where does it cross. We know it crosses at k is equal to 1 and k is equal to 11, right? It's not really accurate here because it's going in the negative direction, but doesn't really matter, right? So we know it crosses at that point, but now since we know the shape of the graph, then we know, okay, anything that's going to be greater than, right? Because we're looking for this direction. We're looking for this area over here. Anything that's greater than 1 and less than less than 11, that's going to give you positive values because that's where your graph is in this area over here, right? So the answers are going to be when k, sorry about that, all right, when k, so when k is less than 11 and also less than 1. Remember, it's not less than or equal to, because equal to, that's when it will then be on the tangent. It has to be not on those points. So it's going to be greater than 1, less than 11. That means your graph is above the x-axis. So hopefully that makes sense, right? So we just trying to understand based on the shape of the graph where the different values of k, what those values would give you out. I'm just going to use one more illustration using Desmos, and then we're done with this example. All right, so we're back on Desmos, right? And again, right, so this is the website, Desmos, which is DESMOS.com. You can just go to the graphical calculator. So I love this website because it shows us what the different scenarios that we're working with, and hopefully it can make a little bit more sense once we've added the stuff in, right? So because in the question, I gave you this circle, and then I gave you this expression here, 2y minus x is equal to k, right? So what I'm going to do is I'm going to add a slider for k, right? And then we're going to try to just take it from 0 to 20, and then make sure that we put a step of 1, right? So these are things that you can put just to play around with it. So what it does is, because we said, okay, when we said different values of k, I just make those, can I make this? No, I can't. Okay. So we said the values between k and 11 were positive, right? So you can see over here, my 1 is a tangent. If I put anything less than that, you see there's no solution because the graph has gone below the x-axis. The graph of determinant versus k has gone below the graph, right? If I put 1, right, so we said it has to be greater than 1 because at 1, it only has one solution. It's a tangent. So that means your graph of determinant versus k is on the x-axis, right? It's on determinant is equal to 0. But now if we slide it anywhere between, because we said it's between 1 and positive 11, we now have those two solutions that we talked about. 2, 3, 4, 5. We have two solutions all the way until we get to a k value of 11. This gave us one distinct solution because it's now back on the x-axis. So now anything that's greater than this, it's going to give us no solutions. So essentially, this is how that works, right? So I do understand that because now we have essentially within this question, you have a quadratic within a quadratic. And I do understand that that's tricky, but hopefully at some, just visualizing the graphs. And if you go on this website yourself and just play around, hopefully it starts to kind of make sense how different k values that you put in here can give you, different values of different solutions just looking at the graph here. So hopefully that kind of makes sense, and hopefully not only do you understand it visually, but also the procedure also makes sense. It makes sense and it's not too confusing. But let me know if if you want me to explain it a little bit better. But for now, I am going to stop this video right here, and I will see you in the next one.